more things with sinusoid.
Okay.
I think more like review stuff because we're test on Wednesday.
You gotten into the phase shift yet, or vertical shift?
Yeah, we've done a couple of those.
Okay, so you've covered all 4 things. So what kind of problems would you like to go over tonight? Turn that beeping down. That's the only problem I have with doing the audio this way. Is it?
Yeah,
it insists on. Okay.
So I've been having trouble with these ones where there's the fraction after the sine or the cosine.
Okay.
So this one is y equals 3 cosine x over 2.
Okay, write that another way where the x has a coefficient in front of it.
The 1/2 x.
And now b is 1/2.
Okay.
It's all right. Which means the period is 4 pi. Because the period is 2 pi divided by b, and b is 1/2.
Okay.
Okay. What else? Let me ask you one question, just so I cover it before I forget.
All right.
What's the phase shift in this one, in number 1?
The shift for that one would just be pi over 2.
Okay. What about number 2?
That would be pi over 2 divided by 2.
Yes. So it doesn't matter what form they give it to you. You have to always make sure you get rid of this coefficient that's in front of the x if it's inside the parentheses by factoring it out. And that changes the phase shift.
Okay.
Okay? Okay? If you have some graphs that need interpreting, you can go ahead and take a picture of them and send them to me real quick.
All right. Yeah, I'm just looking through some of the problems and seeing if there are ones that I don't really.
Have you had any of the word problems yet? Like a tides problem, or a Ferris wheel problem, or a breathing problem, or things like that?
Yeah,
Those are probably the most challenging part of sinusoid functions.
okay, here's one for motion of a buoy.
Okay?
It says a signal buoy in the Chesapeake Bay bobs up and down with the height h of its transmitter in feet above sea level, modeled by h equals a sine bt plus 5. During a small squall, its height varies from 1 feet to 9 feet, and there are 3.5 seconds from 9 feet height to the next. What are the values of the constants A and B?
Okay. C being, it's a funny variable to use. Did you say C? This is sine? T, okay. I was looking at that, and I was going to say, I've never seen anybody use C for that variable, either X or T, but all right. When you're given a minimum and a maximum, how do you get A?
So A would be the maximum.
A would be the maximum minus the minimum divided by 2. In fact, let's draw this because this will help you remember. Because you get A and D in a very similar way. We know A in this curve is 1, correct?
Yeah.
So we got 1 by taking the maximum 1, subtracting the minimum minus 1, which is 2, and then dividing by 2. So it gives us the peak of this amplitude. Okay? And we get D, we get this number, by taking the maximum, adding it to the minimum, and dividing by 2. And notice that if we take 1 and add it to minus 1, we get 0 divided by 2, 0. That is our line of symmetry. Y equals 0. So you get A by subtracting the max and the min and dividing by 2. You get whatever variable you want to call that, whether it's D or I think you said you use 8. What would you say you use for those two variables?
I use H
and K? Okay. To get K, you take the maximum plus the minimum and divide by 2. So that's how we got 5. 9 plus 1 divided by 2. And we get A, which is going to be 4. Now, how do we get B?
That would be so if you found the period and then multiply that by 2 pi?
B is very simple. It's equal to the it's equal to 2 pi divided by the period.
Oh, okay.
Okay, and likewise, if they give you the period is equal to 2 pi divided by B. Just by manipulating that algebraically, you can get that. Okay, well, in this case, they gave us the period, 3.5 seconds. From when the thing is at its peak to when it gets back to its peak. Well, if you look at a sine wave, the period is, you can measure peak to peak, you can measure valley to valley, you can measure x-axis heading up to x-axis heading up. Any of those measure the period.
Okay.
And they're telling us that it was 3.5 seconds. And so B is 2 pi divided by 3.5, which is 4 pi over 7. Multiplying top and bottom by 2, which is what you'd want to do. You wouldn't want to give the answer as 2 pi over 3.5.
Yeah, we would do the decimal there.
Oh, you would? Okay. They would. You would convert it. In other words, they would say B is some number. They wouldn't say 4 pi over 7. I would think they would say 4 pi over 7. In other words, the formula they're looking for is this. The height of the buoy at any point in time is 4 sine of 4 pi over 7 times t plus 5. Yeah. And notice when I was discussing this problem of where the parentheses is, it doesn't affect B. It doesn't matter whether B is inside or outside the parentheses. in determining the period. When I gave you that example before where I think I said cosine of 2x, and I put one of them inside and the other outside, well, it doesn't matter because here b is 2, and when I factor it outside the parentheses, it's still 2. So b doesn't change. The only thing that's affected is that phase shift. Okay? And all of those kind of word problems, that's exactly the way you do it. You calculate A. They always give you the maximum and the minimum. In other words, if it's a tide, they may say high tide is 20 feet, low tide is 11 feet. Well, there's your maximum and minimum. And then they'll tell you when high tide comes in and how many hours later low tide comes in. There's your period. Or actually, your period would be high tide to high tide. Half of a period would be high tide to low tide.
Okay, so another one
Okay.
was, yeah, it's one of those tide problems.
Okay.
An earthquake occurred at 9:40 a.m. I guess that's not really so the earthquake produced waves that traveled more than 540 feet per second and reached a height of 60 feet. And the period of the waves was 30 minutes or 1,800 seconds estimated. Estimate the length between the crests.
They only gave us okay, the time is immaterial also, right?
And it says that 540 feet per second is also 370 miles per hour. I don't know if we'll need that or not.
Okay, I'm trying to get a handle on the periodicity of this. In other words, the sinusoid functions apply to periodic stuff. That's why it applies to breathing, tides, because they go up and down and up and down. That previous problem we looked at, the thing bobs up and down, up and down. So, what are they telling us here? I'm trying to get a picture of what this tidal wave looks like. I guess the tidal wave looks something like a sine wave. 60 feet high. So they're saying that, I'm not sure if that means 60 feet above sea level or 60 feet above the trough. Does it say?
In the picture, it's 60 feet above the sea level. So.
Okay, so that would be 60. A would be 60 then.
Yeah.
A would be 60 as long as we're in feet. Its speed. Wow, this is an interesting one. I'm not sure I've ever done one like this, where the peak travels. Let me think about this for a second. 30 minutes. What does that 30 minutes apply to?
If the period of the waves was 30 minutes or 1,800 seconds, estimate the length incorrect.
Okay. So, if I continue, and this distance here is 30 minutes or 1,800 seconds. I think we're going to want everything in seconds. We're going to use this measurement, we're going to use this measurement, and we're going to use that measurement because they're all in feet and feet per second. Okay. So our period is 1800 seconds. So what is B?
That would be 2 pi over 1800.
So now we've accounted for the 1800, the 60, 540 feet per second. Trying to figure out why that matters. What are we looking for? We're looking for the distance. Ah, okay. Now I know why it matters. Well, we know that it's 1800 seconds between peaks.
Yeah.
And if it's going 540 feet per second, and we multiply that by 1800 seconds, seconds cancel, and we get the distance between the things is 540 times 1800 feet. What is that number? Do you have a calculator? Here, I got one. 540 times 1800, 972,000 feet between the waves. Now, I think that's the answer. I'm trying to think for a second. It would take, now hold on, if there's 1800 seconds between those waves, and yeah, it's going 540 feet per second, it's got to go, for 1800 seconds, it's going to go 972,000 feet. So I think that's our answer. It's an interesting problem because we have a traveling sine wave. But that's okay. In other words, this whole wave is moving like waves do. I've never applied this to a moving wave before. In other words, whatever water is on the crest of that wave right there, 1800 seconds later, it's going to be there. In other words, say you had a what do you call it? What do you ski waves with? A surfboard. If you had a surfboard and you were on top of that wave at 0 seconds, then it would take you 1800 seconds. I think. I don't know. You know, I may have to think about this one a little more. But I think that's the way to do it. I can't imagine any other way of doing it. Yeah, if they wanted the equation, we've got everything we need. We have A, we have B, C, there's no phase adjustment, and D, sea level, so there's no vertical shift. So that's got to be right, I think. You got time for another one, if you have word problems, or maybe a couple more if they're just straightforward problems.
Here.
That's a good word problem. I thought I'd seen them all. I hadn't seen that one. I mean, I've seen the Tarzan swinging on a rope out over a pond. That's a sinusoid problem.
this one. Okay, so this one is negative 2 sine of pi x over 4.
Okay. What do they want to know? I want you to just graph it.
So describe the transformations required to obtain the graph of the given function from basic trigonometric graph.
So that's our basic one. What's the first transformation we're going to do? Let's do them one at a time.
Okay. So it'll be reflected over the x-axis to the negative 2.
So it's going to go all the way down to 2 and up to 2. So that would be minus 2 sine x. Let's label that. That's y equal minus 2 sine x. Okay. What's the other transformation that's happening?
So there would be a phase shift in there, but I'm not really sure.
Not a phase shift, as there's a period change. In other words, this is b.
Oh, I see.
So the period is equal to what?
2 pi over b.
Which is 8. This flipping the denominator and multiplying is something you have to do quite frequently whenever there's a fraction there, because b is always going to be in the denominator. Okay, so if our period is 8, instead of 2 pi, we horizontally stretching this or shrinking it?
That would be stretching.
Yeah. And we can also tell because 2 pi is what, 6.3? Whereas our period needs to go out to 8.
Yeah.
So we make that 8, make that 4, make that 2, make that 6, and draw this blue dotted curve through all of those points. Instead of, in other words, let me do this in red. So our final curve goes down to there, comes up through 4, hits its peak at 6, and comes back down at 8. So that is that curve. Okay. And a lot of times I think that's the best way to do these is one at a time. Unless it's a phase shift. And with a phase shift there's a particularly effective way to do it that's different than one at a time. I used to do my phase shifts different than I do them now. I used to draw the thing unphase shifted and then just move the whole thing over by wherever it needs to move. But I think the best way to do phase shifts now is to find your starting point, find your period, find your ending point, and quarter those 2 points.
Yeah, that's what I've been doing.
Yeah. In other words, if we have a phase shift of, say, minus pi over 2, well, that means my starting point is right there, minus pi over 2. Well, my ending point is going to be 3 pi over 2, because that's a 2 pi period. So if that's 3 pi over 2, that's pi over 2, just quarter that, and then draw your curve from this starting spot to that ending spot. And I think that's the best way to handle phase shifts. And that way you don't have to draw an unphase shifted curve and then try to draw a parallel one next to it, which is kind of the way I used to do it. Any last questions, Daniel?
No, that was a good review right there.
Okay.
Sure I'll have something on Tuesday, but...
Okay. Let's see. Do we have a standard on Tuesday? Did we decide that? Or you just have one scheduled for Tuesday? Let me just check. Let me check my calendar here, make sure I got you down for next Tuesday. You know, I don't. Oh, yes, I do. I'm sorry. I got you down at 7:30. So that's going to be your standard one. That's right. We talked about that. Yeah.
Yeah.
Okay. Sounds good. I'll talk to you Tuesday.
Well, hold on a sec. So, about paying you. My parents, is there a way to pay you without using PayPal?
Sure. They can send me a check if they want.
All right.
Let me write my address.
Okay.
And make it out to me. I mean, I've had people make it out to algebra to calculus tutor, and I can't cash those.
All right.
I don't have a business account. If they want, I can send them an invoice.
Send them a what?
An invoice? A bill? At this point, I think it's $54, isn't it? It was one full session and one half session.
Yeah.
But I keep pretty good track. I have a pretty good accounting program, and so if they need me to, I can send them an invoice.
Okay.
But I won't for this one.
All right.
Just let them.
Yeah, I'll
Okay.
for a few payments.
Sounds good.
They're in the past they just for whatever reason don't really like PayPal.
I'm sorry, what?
I thought ask if that just for whatever reason they don't like PayPal.
Oh, I don't blame them. I don't particularly like it either. They take 4%, so I'm better off getting a check. But PayPal is awfully convenient. You can't beat it for convenience.
All right.
Okay? All right. Have a good weekend, and I'll talk to you Tuesday night.
Thanks.
Bye-bye.